Okay, so this is 2014 ADMA paper 2. This was question 9. Very easy. So, like I said in the other videos, all you need to know here is how to solve simultaneous equations. So, you should be able to look at the question and make two equations which you can solve simultaneously. Okay, so the eighth term, so you can say the eighth term of a GP, so we are dealing with a geometric progression, is 32, and the fourth term is 2. Find the first term and the positive value of the common ratio. So you know that the nth term of an AP is given by A plus, this is a GP. The nth term of a GP is given by A r to the power n minus 1. So you can simply say the eighth term is given by A is unknown, r is unknown too, so you can put an 8 where you have an n, and then you do the same thing here. So the fourth term will be a r, then 4 minus 1. But then you know what t sub 8 is, or the eighth term. This is 32. So you can simply write your 32 there. Then this will be ar to the power 7. Then this side you have t sub 4 is equal to 2. So you can just write the 2 there and have this. This minus this is 3. So the easiest way of solving these kinds of simultaneous equations is by making A the subject of the formula, because making R the subject of the formula will be a lot of work, and in most cases you have cube roots in this case, and then you have the seventh root there. So I'll make R the subject of the formula, A, so I can divide both sides by r to the 7, so that my A is equal to 32 over r to the 7. Then I can do the same thing there, divide both sides by r to the 3, so that my A here is equal to 2 over r to the 3. So now, since these are both A's, in fact you can even substitute this directly into that. But I think it's better when you do it like this. So I can substitute this in there and say where we have an A, or maybe this one in there. So instead of having an A here, I can substitute this. So I have 2 over r to the 3 is equal to 32 over r to the 7. And then you can simply cross multiply if you want, and solve for r. So this by this will be 32 r to the power 3. This by this will be 2 r to the power 7. And then you can have all the r terms on one side and all the non-r terms on the other. So to do that, I can start by dividing both sides by 2, so that I have 16r to the power 3 is equal to r to the power 7. And then further, I can divide both sides by r to the 3, so that this and that goes. And then using rules of indices, you agree with me that we can just subtract the powers. So 7 minus 3 here will be 4. So if you want, you can use natural logs, or you can just write this in terms of you can just write this in such a way that the power is a 4. So to write 16 with a power 4, the base must be a 2. So this will be 2 to the power 4 is equal to r to the power 4. And since the powers are the same, we can conclude that the bases are the same. So this will be equal to 2. And then secondly, find the first term and the positive value of the common ratio. Okay, so we have found the common ratio. Now we can find the first term. You can use any of the two equations. So since this is much easier for me, I'll go for it. So the first term will be given by 2 is equal to r to the power 3. So this will be 2 over, our r is 2. So I can write 2 to the power 3. So this one will be 2 over 8, which is 1 over 4 as your A. And you are done with part A. So for part B, this is actually the easiest. Find the sum to infinity of a GP whose first term is 5. Yeah, so the first term here is this. So our first term is 5. And then the second term is let's just call our first term as term 1, then the second term as term 2. It's okay to write this, by the way. So now, from the formula for the sum to infinity, it's simply A over 1 minus R, where R is between -1 and 1. So this cannot be 1 point something, it has to be 0 point something all the time. So to find the R, remember we already have the A, it's a 5. So to find the R, you simply say R is equal to T2, actually capital letter T2, divided by T1. Remember, this is the common ratio, and you always have to start with the second one. You use the second one as your numerator, and then your first term as your denominator. So this will be your R. If you want, you can even write it in decimals as 0.8, I think. Yeah. So now, the sum to infinity of such a series will be A, which is a 5, over 1 minus 0.8, which is our R. And then you can just simplify this. So this minus this, remember this will be a plus, so this will be 1.8. And then you can simplify it further, but I don't have my calculator and I don't want to deal with such numbers, so I'll leave it here. Lastly, we have this one, the nth term of an AP. So the nth term of an AP is given by 3n plus 7. So this is like an expression for the nth term. Any term. So if I want to find the first term, I simply put my did I say my first term? Yes, if I want to find my first term, I just put a 1 there and a 1 there, then I'll have the first term. If I want to find my 10th term, I just put my 10 there. So now this is given by this. So find the sum of the first 40 terms. So to find the sum of the first 40 terms, remember the formula is given by, and this is always provided, the formula is given by this. You know the n, that would be a 4, but you don't know what the a is and you don't know what the d is. So to find your a, remember a is the first term. So to find the first term, you can just put a 1 there. So this one will be 1 again. So this times this is 3 plus this, that would be a 10. So our first term is a 10. And then to find the d, you can just find the next term and subtract. Remember, the d is the common difference. If you have numbers like this, and this maybe, the d will be the distance from here to there, the distance from here to there, or the gap between this and this, or the difference between this and that. That is what we call the d. So to find this, I can simply find the second term. So the second term will be given by putting a 2 there, by this. So this times this will be a 6, then plus 7, this plus this will be a 13. So now to find the common difference, remember this is the difference between two consecutive terms. Of course, you have to start with the next term, not the first. So in this case, the second term. So you have 13 minus 10, which is a 3. So the sum of the first 40 terms, the question is asking you to find the sum of the first 40 terms, will be given by, I'm using this formula, 40 divided by 2, and then 2, instead of writing an a, we know that a is 10, then plus, instead of having an n, we know that n is 40, so we can say 40 minus 1, our d is 3, like that, and then this into this will be 20, and then 2 times 10, this is a 20 again, then this minus this is 19 times 3, 3 times 9 is 27, 3 times this plus that would be 57, I think, and then this will be this, and then 20 plus 57, this will be 77. Then when you multiply these two, you have 154 and a 0 at the end. So this is the sum of the first 40 terms of an of an AP like this. I thought we were dealing with a GP. Yeah, so this is your answer there.